Good morning, dear students. Welcome to the science class. Today we continue our discussion on chapter 2 acids, bases, and salts. In today's class, let us learn more about salts, preparation, properties, and uses of salts. First, let us see the pH of salts. Collect the following salt samples: sodium chloride, potassium nitrate, aluminum chloride, zinc sulfate, copper sulfate, sodium acetate, sodium carbonate, sodium hydrogen carbonate, and check their solubility in water. We are using only distilled water. Check the action of these solutions on litmus and find the pH using a pH paper. Which of the salts are acidic, basic, or neutral? Identify the acids or base used to form the salt and report your observations. Let us see. Sodium chloride, it is neutral in nature. The pH value is 7. The acid used is hydrochloric acid. Base used is sodium hydroxide. Potassium nitrate, acid used, it is neutral in nature. pH value is 7. Acid used nitric acid. Base used potassium hydroxide. Aluminum chloride, acidic in nature. pH value is below 7. Acid used hydrochloric acid. Base used aluminum hydroxide. Zinc sulfate, acidic in nature. pH is below 7. Acid used sulfuric acid. Base used zinc hydroxide. Copper sulfate, acidic in nature. pH value is below 7. Acid used sulfuric acid. Base used copper hydroxide. Sodium acetate, acidic in nature. pH value below 7. Acid used acetic acid. Base used sodium hydroxide. Sodium carbonate, basic in nature. pH value above 7. Acid used carbonic acid. Base used sodium hydroxide. Sodium hydrogen carbonate, basic in nature. pH value above 7. Acid used carbonic acid. Base used sodium hydroxide. So salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of strong acid and weak base are acidic with pH value less than 7. And those of a strong base and weak acid are basic in nature with pH value more than 7. So this is a conclusion. The salts of strong acid and a strong base are neutral with the pH value of 7. Here you can see a strong base sodium hydroxide and a strong acid hydrochloric acid. Then you get the salt sodium chloride, the pH value is 7. On the other hand, salts of a strong acid and weak base are acidic. Here you can see. And those of a strong base and weak acid. Strong base and weak acid, you can see the pH value is above 7 and nature is basic salt. So chemicals from common salt. The salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is a salt that we use in food. So the combination of hydrochloric acid and sodium hydroxide will get sodium chloride. It is a neutral salt. Seawater contains many salts dissolved in it. Sodium chloride is separated from these salts. Deposits of sodium salt are also found in several parts of the world. These large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt were formed when seas of bygone ages dried up, and rock salt is mined like coal. So that's about common salt. Then a common salt, a raw material for chemicals. The common salt thus obtained is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, the aqueous solution of sodium chloride is called brine. When electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. You can see the reaction here. It decomposes to form sodium hydroxide. The process is called chlor-alkali process because of the products formed. Chlor for chlorine and alkali for sodium hydroxide. So chlorine gas is given off at anode, this is anode, and hydrogen gas at the cathode. Sodium hydroxide solution is formed near cathode. The three products produced in this process are all useful. Let us see the different uses. Before that, once again, let us see the chloralkali process. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide, and the process is called chloralkali process. Chlor stands for chlorine and alkali for sodium hydroxide. So the uses of sodium hydroxide. It is used for the manufacture of paper, used for making soaps and detergents, used for making rayon and artificial textile fiber, used for degreasing metals. Uses of chlorine. It is used as water treatment, used in the production of bleaching powder. It is also used in the production of hydrochloric acid. It is used to make plastic, pesticides, chlorofluorocarbon, chloroform, carbon tetrachloride, paints, etc. Uses of hydrogen. It is used as a fuel for rockets. It is used to make ammonia for fertilizers. It is used in the hydrogenation of oils to obtain vegetable ghee. So these are the various uses of sodium hydroxide, chlorine and hydrogen. Dear students, this is all for today's class. Hope you all have understood it. Thank you.